Now let's move on and do our first actual ellipse problem. We can look at this and see that it's got fraction plus fraction equals 1. We've got x squared plus y squared equals 1, and that tells us it is an ellipse. Now, we want to first identify the center, and I'm going to write it over here. The center is located at -2, +1. We get that by changing the signs of the values within those parentheses. And the next thing I want to do is take a look at these values in the denominator. 16 is our a squared. We're going to square root that to 4 to get a equals 4. Let me write a equals. And then the square root of b squared, which is 4, is going to give us b is equal to 2. Now those are two key values we need when it comes to drawing our ellipse. I'm going to go straight to our picture for starts. -2, 1 is where we will plot our center. And then notice how this 4, a is 4. We've already said that that will be the distance between our center and our vertex. Notice how it's beneath the x fraction, and the x variable always refers to left and right movement. So from this central value here, I'm going to move 4 units to the left and 4 units to the right. And then looking beneath the y fraction, we've got a value of b equals 2. We're going to go 2 units up and 2 units down, and this will give us the 4 points through which we will draw our ellipse. And I'm just going to eyeball that as best as I can. Excuse me if it's not perfectly smooth. And that becomes our ellipse. Notice how the horizontal axis is longer than the vertical axis. We say that this is a horizontal ellipse, and that the major axis is horizontal. Notice that the major axis, which is 4 units to the left and 4 units to the right of the center, is 8 units long, and the minor axis, the short one, is 2 units up and 2 units down, so that is 4 units in length. Now, if we wanted to identify where the foci are, we would use little c squared equals the difference of the denominators, 16 minus 4. So c squared will equal 12, and c is equal to plus or minus 2 root 3 when you square root both sides. Now, the foci, it turned out, are always on the major axis, and this major axis is horizontal, so we are going to be moving that 2 root 3 left and right of center when we identify the foci. Now, left and right means it's going to affect the x value here, and when we go to state our foci, that'll be -2 plus or minus 2 root 3, comma 1. Okay, and now the square root of 12, that's 3.5-ish. And so those two foci I'm drawing in now into our graph are pretty much right where I've got them located. As the foci are further away from the center, the curve becomes more elongated. As these two foci are drawn in closer towards the center, the graph is more circular until those two foci touch each other, and then they all really are only one point. Then you actually have a circle itself. Okay, with this problem, we see x squared plus y squared equals 1 with two different denominators. That tells us this is an ellipse. We notice no values of h and k up in the numerator, so we know that the center for part A is located at the origin, 0, 0. A is always going to be found by looking at the larger denominator. Our larger value is 64, so a squared is 64, which implies that a is going to equal 8. And b squared is the smaller denominator, which is 49. Since b squared is equal to 49, that tells us that b is going to equal 7. Now this 8 basically tells us it's going to be 8 units left and right to get to the vertices of the curve, and we know it's left and right because that 8 is in the x fraction, and this y fraction gives us the number 7, and that tells us we're going to be going up and down 7 to get to the endpoints of the minor axis. So if we start at our center, which is at 0, 0, and we're going 8 to the right and 8 to the left, the vertices are going to be located at -8, 0 and +8, 0. If we want to find the endpoints of the minor axis, we're starting at the center of 0, 0, but we're going up and down 7 units, and so that tells us they will be located at 0, 7 and 0, -7. To identify the foci, you're going to begin with the equation c squared equals a squared minus b squared, and you're going to subtract those two denominators, 64 minus 49, which gives you 15. C squared equals 15, and c will be plus or minus root 15. Now, we know that the denominator of x is larger, therefore the horizontal axis is the major axis, and since the foci are on the major axis, we will be moving left and right of center to find those foci, and they will be located at negative root 15, 0 and positive root 15, 0. As far as the length of the major axis, we've already said we're going 8 to the left and 8 to the right, so this will be 16 units long. And as far as the length of the minor axis goes, we already said we're going up 7 and down 7, so the minor axis will be 14 units in length. If we go to graph this entire curve, yes, it's centered at the origin. We are moving 8 units to the left, 8 units to the right, up 7 and down 7, and even though it looks pretty circular, it actually is a little bit more stretched in the horizontal direction. And this warped out thing is supposed to be my ellipse, and we said that at the square root of 15, which is just under 4 units to the right and just under 4 units to the left, will be where we find those two focal points for this curve. Note that the focal points are not part of the curve, nor is the center part of the curve. The ellipse is actually just the curve itself.